Hi, everybody. Welcome back. We are going to take a look today at Chapter 6, Part 1, Early Childhood. This will be the physical development portion. Once again, I'm Professor H, and we are just plugging along, trying to get these videos done. So I appreciate your patience, and let's go ahead and get started. All right, so I'm going to start off with our screen share. Get us over to our PowerPoint. All right. Okay, so Chapter 6, Part 1, Early Childhood Physical Development. We're going to take a look at nutrition and growth from the ages of 3 to 6. We're going to take a brief look at brain development, look at the improvements in gross and fine motor skills, and take a peek at handedness. Physical development still is proceeding at a rapid pace, but it is a lot slower in early childhood than it has been. So at this period of development, children have basically begun to lose all of that baby fat. They begin to increase in their muscle mass, decrease in the amount of fat. They can regulate their temperature well and everything by the time they're in early childhood. They become a lot longer and leaner. In developed countries, we see an increase in height from 2 to 3 inches per year on average, and we see an increase of about 5 to 7 pounds per year on average, where a 3-year-old would be about 35 inches tall and weigh about 30 pounds. Our average 6-year-old is about 45 inches, I put feet on the thing, about 45 inches tall and approximately 45 pounds. In developing countries, growth is similar. However, it is progressing a bit more slowly. There are lower gains in weight and height, and that is oftentimes due to poor nutrition and childhood disease. So you don't see as many gains in children in developing countries. Something that we see as a result of poor nutrition and just not having everything available to them that is needed, the micronutrients and all of that, is something called stunting. Stunting is a process where children end up quite a bit shorter than their normal peers would be at that same age, and that is due to being malnourished. So if we have 2 kids that are, 2 6-year-olds, one would be a lot shorter than they technically should be due to malnutrition. That would be stunting. There are some long-term effects of stunting, not just because they're shorter. There's also other physical and cognitive problems as well. Globally, about 23% of children under the age of 5 are stunted. Some areas of the world are over 30% of stunting that have stunting. So this is an interesting graph from the World Health Organization. I wanted to bring this to your attention because any statistics that you're interested in that we've talked about in our class, you can probably find on sites like the World Health Organization site. And what I'm going to do is I'm going to go ahead and take us out of this PowerPoint real quick, and we're going to take a look at this site. So let me end the show, and I'm going to do a new screen share real quick. And we're going to take a look at this site. Okay, this is the World Health Organization's website, and on it there are a lot of really great graphs that can show you details about things like stunting. This particular graphic is child age 5 years stunted. So in other words, it's children 5 and under 5 years that are stunted. This is from 1985 to 2018, the percentage of height for age. Anyway, this is with their standard deviation. This is their graph. So what we can take a look at here is we can say, okay, these are the different regions, global regions that we're looking at. Let's take a look at the Americas since we live in North America. And if I click on this bar, we can see a lot of different countries in the Americas. What I noticed is that Canada is not here. I'm not sure why. Maybe they don't have the data for Canada. Maybe they didn't I don't know why Canada's not here. But as you can see, our highest rate of stunting, according to the World Health Organization, in the Americas is Guatemala. So there is a high percentage of children here that are stunted in Guatemala. So this talks about in this particular country, when you can see this graphic that I pointed out here, when I put it on the bar, it's giving me statistics. Guatemala, 46.7% of the children in Guatemala are stunted due to lack of nutrition, lack of micronutrients. For the region of the Americas, the average for that entire region, which is like North and South America and Central America, 6.5% of children. And globally, our average number is 21.9. Let's take a look at the United States. See if I can get it on here. In the United States, 3.5% of children are stunted. And then it gives those other same statistics. So I just wanted to point this out to you because this is a pretty neat tool. When you're interested in any of these areas, you can go on to the World Health Organization and look at their graphs, and they're very interactive like this, which are kind of nice. All right, we're going to return back to our presentation now. Get us, if I can find the right screen. There we go. Okay, we'll go back to our slideshow. So this is just a picture of that graph. In developing countries, there is a big gap between the wealthy and the poor. And I know we do see that somewhat in developed countries as well. We talk about that a lot in the United States. However, in developing countries, there is a very wide gap between wealthy and poor, and there are very few in the middle. Interestingly, when we talk about nutrition and health of children in developing countries, and we consider socioeconomic status, there is something interesting that we see when it comes to obesity. In developed countries like the United States, we see higher rates of obesity in our poor people. People who can, basically, it's a lot cheaper to buy foods that are high in fat, high in sugars, low in nutrition than it is to purchase vegetables and have to prepare vegetables and doing all of that. So a lot of times some of our more poor families end up spending their limited funds on food that maybe goes further but is less nutritious. So we see a lot of obesity in our lower socioeconomic status groups. In developing countries, it's the opposite. What we see is we see children that are obese being in wealthy families because they have greater access to these foods that are high in fat, high in sugars. So it's just kind of an interesting thing that we see. It's very different globally. It's not the same as in the United States. In these developing countries, it is the wealthy children that are more obese or have a higher rate of obesity. During our early childhood period, we see some changes in teeth. By the time our child is 3 years old, they should have a full set of 20 teeth. These are their primary teeth, which we call their baby teeth. From ages of about 6 to 13, they start to replace these baby teeth with their permanent teeth. And that gives us the cute little smiles that these girls have that we're seeing in our pictures here, where they've got some missing teeth going on. By the time after they're 13 years old, when all of their baby teeth are replaced with permanent teeth, they should have a full set of 32 teeth in their mouth. Interestingly, there are some differences in our dental care, obviously. In a developed country, a lot of times children go to the dentist as early as 3 years old. In a country like the United States and the UK, children are taught to brush their teeth, care for their teeth. They can receive fluoride treatments, sealants, things like that. And once again, if you are in a lower socioeconomic status, oftentimes these things are not covered by insurance. So there is definitely a divide in the dental care that you receive based on your socioeconomic status in the United States. 30% of American children have at least one cavity between the ages of 2 and 5 years old. This is thought to be due to inconsistent tooth care and diets that are very high in sugars and starches. Even when you go to McDonald's or somewhere like that, there's a lot of sugar added to the sauces and such, or high fructose corn syrup. So our diets in the United States are much higher in sugars. In developing countries, there are less sugars and starches being consumed by these children. However, according to the World Health Organization, we still see more decay in early childhood. This could be as a result of lack of good oral hygiene. And the other part is if they are missing essential nutrients such as calcium or other micronutrients, they may not have as much protection in place for their teeth due to their poor nutrition. Next, we're going to talk about brain development. The brain grows in volume slowly. Slowly. At 3 years old, the infant brain or our toddler's brain is at about 70% of the adult size and weight of that adult brain. By 6 years old, the child in early childhood has about 90% of the adult size. So their brain is about 90% of the size of an adult brain. So they're pretty close. They're getting, that's why they still have a little bit of a big head. And as we looked at a chart earlier that showed the differences in the head size compared to the rest of the body, which was kind of interesting. And this is different because if we compare the overall size and weight of the child, a child at 6 years old is only about 30% of the weight of an adult, whereas their brain size is 90% of an adult brain size. So it's just kind of some differences in how the brain grows and develops compared to how the rest of the body is growing and developing. These increases in brain size that we see are due to myelination and synapses. If you recall from our previous lecture, myelination is when the axons that are sending the signal down the neuron are wrapped in a myelin sheath, which is a specialized type of cell that wraps itself around the axon to create the signals, to enhance the signals so that the signal can travel a lot faster down the axon when it is myelinated. So this is part of the reason why that brain weight is increasing. The other thing is creating more synapses, and we talked a little bit about that. Those synapses are those little communication gaps, so that as the child learns and grows, they're building more and more and more synapses. And as you're learning this information, your brain is creating more synapses related to the material that you're learning. So this is one of the reasons that we see this great amount of brain growth in brain growth in this period of time. The frontal lobes of the brain grow faster than other brain areas. These are the areas important for planning, emotional regulation, foresight. That means like kind of being able to look ahead and see how something might turn out, and planning. The growth in the brain occurs in spurts. Kind of like we talked about, height can be occurring in spurts where you have kind of overnight, a kid can grow a lot. Well, with the brain, we have spurts that occur as well, where we have periods of exuberance, which means that we have tons of synapses occurring, new synapses. And then we have periods of pruning where things we're not using are pruned back so that we can expand into those areas with the synapses that are related to things that we need to know. Other brain changes that we see. Okay, there are 4 main areas that increase in myelination during early childhood. That is the corpus callosum. The corpus callosum is a large fiber bundle that connects the right and the left hemispheres. Remember, if I were to split longitudinally like this, I would have one half here, I don't know my right from left, but you'd have a right and a left hemisphere that you would be looking at. And that corpus callosum is what allows for the communication between those two halves of the brain. This corpus callosum continues to myelinate all through adolescence, but at a slower pace than it does in early childhood. The cerebellum is an area in the back of your, kind of the lower back of your brain. I'll show you where that is on a diagram that we have coming up. It is very important for motor movements. It helps to coordinate the ability to throw, jump, that motor coordination. As you get more myelination in this area, you see more ability to have precise fine motor movements or even some of the larger muscle movements. There are a lot of diseases that affect the myelination of the cerebellum that lead to ataxia or a inability to control your motor movements well. Reticular formation is another important area of the brain that is important for attention. 4 to 5-year-olds can sit around for about 10 to 15 minutes, which is way longer than a toddler can. And this is, we believe a lot of this is due to the maturation of this particular brain area, this myelination that is occurring. The hippocampus is another area that undergoes a great deal of myelination. By about 5 years old, it is believed that the hippocampus becomes fully myelinated, meaning that that particular brain area is good to go and fully formed. This is an important area for long-term memory and consolidation of memories. It helps us to transfer that information from short-term memory into our long-term memory. And this is an area that, area of the brain that we believe is matured by the age of about 5 years old. This is the image I was talking about. The cerebellum is this little cauliflower looking part down here. Once again, this has got that longitudinal half of the brain that we're looking at. This is the corpus callosum, which is that fiber bundle, and several other brain areas. I just kind of wanted to show you where these things are in general. There is something called infantile amnesia, which is very interesting. Infantile amnesia is the inability to remember things before the age of about 5 years old. There are a few people that have a particular condition that allows them to remember everything. They don't do a lot of forgetting, and that is a double-edged sword. But infantile amnesia specifically relates to not being able to remember stuff before the age of 5 years old. It is thought that this occurs due to the immaturity of the hippocampus. This area is still myelinating and therefore, and making more connections, making more synapses. And prior to the maturity of this brain area, it is thought that you might not be able to form memories and store them into, or store these memories into long-term memory. They won't have that consolidation into long-term memory. Interestingly, you do remember some things. You remember how to talk, you remember how to walk, how to do stuff, how to use the toilet. You remember all of those things. So you remember your habits, all of that general information, but what you don't remember, and that's all part of your semantic memory. Those things that I just mentioned are part of your general knowledge. You don't forget that general knowledge, but what you do seem to forget is episodic memory, and specifically a type of memory called autobiographical memory, which is your memory for specific events that have to do with you. For example, being lost somewhere, or getting a particular thing that you really liked for your birthday when you were 4 years old. Oftentimes, these memories are not retained. People are reminded of these memories oftentimes by their parents, but for the most part, most people do not retain that information. There is an exception to this, and that is trauma. Children who undergo trauma have a tendency to retain some memories related to that trauma. That could be basically a evolutionary adaptation so that, you know, in order to protect yourself in the future. But that is something that we have documented with research, is that childhood traumas are often retained, at least somewhat, prior to the age of 5. Interestingly, there are cultural differences in infantile amnesia. In a study by Indell in 2013, American, I don't have AM instead of US. Anyway, American and UK adults remembered more events prior to the age of 5 when compared to Chinese adults. What they found was that on average, people from the United States or from the UK could remember events at about 6 months earlier than Chinese individuals. One of the possible explanations for this is the individualistic versus collectivist cultures. It is thought that it is possible that in a collectivist culture, it's not as important to remember those individual things that are happening to you as much as it is to remember things that have to do with the group as a whole. Health, nutrition, and safety in early childhood. In early childhood, children are less vulnerable than infants or toddlers when it comes to their health, nutrition, that sort of thing. It's still important that they receive adequate nutrition, but it is not as life-threatening. Increased rates of injury. Okay, this period of life, you have a lot more injuries occur than any other periods of the lifespan, and we'll take a look at that in just a minute. Physical growth is slower than earlier periods. We already mentioned that. And their food consumption slows. Sometimes parents get very stressed out and very worried because their children are only having, like, you know, 3 little bites of something for the day. Well, unfortunately, that is a normal-ish part of growing in this time period. There are periods where children will eat a great deal, and then other periods where children will only consume a small portion of food. And that is normal unless there is some type of disease or illness present. Children during early childhood often have periods where they're not eating very much. Okay, so what is it that our kids are eating when they decide to eat? Well, basically, they're eating what their parents feed them. There are definite cultural differences in what children eat. For example, in Japan, children are going to eat sushi since their parents are eating sushi. In Mexico, they might eat chili peppers. In North America, what are they going to eat in North America? Well, unfortunately, the North American diet is a very poor diet, typically. Kids, there is a myth in North America that says that kids only eat a small range of foods, things like burgers, hot dogs, fried chickens, mac and cheese. Oh, that's all my son will eat. That's all my daughter will eat. They only like hot dogs and mac and cheese. That's all I can get them to eat. Foods that are high in sugars, high in fats, and children are oftentimes bribed to eat healthier foods. For example, if you eat 3 more carrots, I'll give you some ice cream. And this kind of sets a precedence for their life that says healthy foods are something to endure and unhealthy foods are a reward. And this type of eating pattern kind of sets us up for failure throughout our life, because when children are young, they will learn to eat what you eat. If you have a really terrible high-fat, high-sugary diet, that is the diet your kids are going to have. If you are somebody that eats a lot of fruits and vegetables, whole foods, that kind of thing, then that's what you feed your children are going to develop a taste for those things, because they will develop a taste for the type of foods they're used to eating. However, our physiology has a tendency to love high-fat and high-sugary foods. So minimizing those in early childhood is really important to set a pattern for healthy eating throughout life. Nutritional deficits in the US. Most of the nutritional deficits we see, I would say the majority of them, are due to eating unhealthy foods. The biggest deficit that we see in the United States is a deficit in calcium. 1/3 of children 3 years old or less have less than the recommended amount of calcium. Now remember, calcium is important for our teeth and our bone growth. What we see patterns of in the United States is children drinking less milk and more soft drinks, having less vegetables that are high in sources of calcium, like beans, peas, broccoli, and dairy. And we're not seeing kids eat as much of that, so that's where that calcium deficit comes from. Latino and African American families, we see higher levels of soft drink usage, and they have lower calcium levels. And these are just averages. I'm not saying that every family is the same, every Latino family, every African American family, every white family. These are just what the patterns and the statistics are showing, that the Latino and African American families have a tendency to consume more levels of soft drinks, and then they show less calcium than whites. So they have larger calcium deficits than white people. And this is partially due to a lower socioeconomic status, because we see a lot of African American and Latino people that are in those lower socioeconomic status and may have more of a difficult time obtaining healthy foods. Interestingly, a study by Hogue et al. 2014, which you can find the references to all of these studies in your book, in your textbook, that moms born outside the US have a tendency to provide healthier diets for their kids. In developing countries, malnutrition is the norm. The World Health Organization says 80% of children lack sufficient food or essential nutrients worldwide. The two most common deficits are protein deficit. 25% of children under the age of 5 experience marasmus or kwashiorkor. And remember, marasmus was that overall starvation where you have a very, very skinny, thin child, and that kwashiorkor is where they have the very distended belly, where they're having a serious protein deficit. Iron is another area where we see deficits, and this leads to anemia. The majority of children, and this anemia is important because it reduces the functioning of the immune system. The majority of children under 5 that experience anemia have fatigue, irritability, difficulty sustaining attention, cognitive and social developmental impairments that are long-lasting. Foods that are rich in iron are meats, which are very that there's not a lot of in a lot of areas of the world. And then there's vegetables like potatoes, peas, beets, and then there's grains like oatmeal and brown rice that are very high in iron. Young children in developed countries may also have anemia due to their poor diet. And then of course there are other health issues that can cause anemia, but one thing that we do see is that children that are eating a poor diet can end up with anemia even in a developed country. All right, moving on to causes of death in early childhood. 90% of childhood deaths worldwide or in developing countries are due to disease. Things like malaria, measles, pneumonia. 50% of these deaths are indirectly linked to malnutrition. And as I mentioned previously, when a child does not have adequate nutrition and they have these deficits, for example, in iron, they will have a reduction in their immune functioning, which will lead to opening the door for disease to occur. Malnutrition impairs the immune system function, which is what I just said. Rate of death reduced by 1/2 from 1990 to 2015. So these levels of death have been reduced, and that is mostly due to vaccinations, because a lot of these childhood diseases that we see kids dying from worldwide are preventable by the use of vaccinations. The other thing that has made a huge impact on reducing the numbers of children dying is improved food production. Having different areas of the world being able to produce food in a better way, more where they can produce more food. Causes of death in developed countries. Well, we don't see the high level of disease in developed countries that we see in developing countries. And this is mainly due to vaccinations. Vaccinations in developed countries are routine. Medical care is more accessible for children in early childhood in developed countries, and life-threatening illnesses are rare. However, minor illnesses are very common in developed countries. 7 to 10 illnesses per year for your average middle childhood kid. These minor illnesses help build their immune system. They develop immunities to these little bugs that they have, which just contributes to their overall immune functioning. And then as they get older, they have fewer and fewer minor illnesses. The major cause of death for kids in developed countries is accidental death. And one of these is one of the main accidental deaths that we see are auto accidents. This is just a little World Health Organization child mortality graph. You can find this on their website. They have all kinds of interactive stuff on there. For our newborns, we're looking at all of these things, preterm birth. We've already gone over all this stuff. And then with our children, we're looking at diarrhea, pneumonia, other infections, malaria, non-communicable diseases, injury right here, and some of these other diseases. Many of the diseases are preventable. As mentioned previously, this period of life is when we see the most injuries occurring. This is due to having an increased level of activity. They're developing their coordination and their skills, but their planning and their judgment is not as good as it could be later. So they might be saying, yeah, I can jump off of this thing, but not really understand that it's too high for them to jump off safely, and they may, fall over and break an arm or something. This is due, once again, immature cognitive functioning. Most common injuries that we see in childhood is falling. Falling is a big one, falling off of something, or they are struck by something, or struck by another person, or they are bitten by an animal. Those are the most common injuries that we see. Boys are more prone to these childhood injuries than girls. And in developed countries, I don't know what that there's for, but this is basically that in developed and developing countries, we do see both of these things. All right, let's talk about changes in motor skills. During early childhood, we're basically just seeing the abilities that were achieved in toddlerhood being expanded upon. So where a 3-year-old could hop on one foot, or maybe go upstairs holding a railing, and maybe one foot and then another foot on the step, and then the next step, one foot and then the other foot, and then the next step, one foot and then the other foot. By 6 years old, they can basically go up the stairs with altering feet, probably not even hold the railing. They can hop one-footed, where the 3-year-old could only hop maybe with 2 feet, or maybe if they can hop on one foot, but just for like one hop. And although our 3-year-old can run, our 6-year-old can run, change direction, stop and start suddenly. So these gross motor skills are just being developed further. Fine motor skills, kind of the same thing. In toddlerhood, our toddler can hold a crayon, they can scribble, they can pick things up with their fingers, but our 6-year-old has a lot more dexterity. They can draw shapes. They can make a circle that looks like a circle, a square that looks like a square. They can start to draw letters. They can draw a picture of an animal or a person. They are starting to learn words and be able to write words. They can put their clothes on properly. Oftentimes they're starting to tie their shoes, use scissors, brush their own teeth, and they could even use a knife for soft foods. So these fine motor skills are just improving. The last thing we're going to talk about is handedness. Handedness refers to whether you are right or left-handed. There is a preference. There's about 90% of people are right-handed. Now, is this due to nature or due to nurture? This is a tough one. We believe that our researchers seem to believe that there are factors related to both. We do see like left-handedness kind of running in a family where we see, several members of one family being left-handed as opposed to right-handed. There are preferences observed in the womb. You could see one of these ultrasounds where a baby is sucking a particular thumb, where they tend to want to suck the right thumb more or the left thumb more, and that's kind of an indication of handedness. If they're sucking their right hand, they're probably right-handed, or sucking their right thumb, they're probably right-handed. And interestingly, when we look at the case of identical twins, now remember, identical twins are genetically 100% the same. So our identical twin is from one egg that has split, so their genetic material is exactly the same. So if handedness was due only to genetic preference, just genetically determined, then our identical twins would either both be right-handed or both be left-handed. However, that is not what we see. We see that identical twins are more likely than other siblings to differ in their handedness, meaning that our identical twins are more likely to have one that's right-handed and one that's left-handed. Well, since they're identical, that must have to do with an environmental factor. And what has been discovered is that identical twins lay in opposite ways in the womb. So one is laying more on the right side, one is laying more on the left side. So the arm that's on the top would be the one that they're using more and become the dominant hand. Interestingly, those identical twins, like I said, are more likely than other siblings to differ in handedness. Another interesting thing about lefties is that they process language in a different area of the brain most of the time. For most right-handed people, their language processing occurs in the left part of the temporal lobe, or in the left side of their brain, in a couple of different areas on the left side of the brain for right-handed people. For left-handed people, it can be on the left, it can be on the right, it can be in several different areas of the brain. So we do know that with left-handed people, language processing is often different. There are cultural biases to being right-handed. In a lot of cultures, left-handedness is related to evil or dangerous behaviors. And in many cultures, in the majority of cultures, the development of left-handedness was suppressed, including here in the Western countries as well. In Western language, the word sinister comes from Latin, meaning on the left. So that's kind of an interesting tidbit there. And then our parents or grandparents can tell us stories about how they were not allowed to use their left hand. They had to learn to write right-handed. They had to be able to do everything right-handed. They weren't allowed to be left-handed. In African and Middle Eastern countries, the left hand is reserved for wiping after you use the bathroom, and it is not to be used for anything else. All other activities are to be done with the right hand. So that is a cultural difference with handedness. In the United States, right or left-handedness right now is like, at least in the majority culture, it is okay to be left-handed, it is okay to be right-handed, and that is no longer suppressed. But in many areas of the world, that is not how it is. In Africa and China, 1% of people are left-handed because it is not culturally tolerated. 10% of people in cultures that are open to left-handedness are left-handed. 90% are right-handed. However, in these cultures that do not accept left-handedness, as we see on this slide, 1% is all we see that are left-handed. All right, that's it. All righty, so that's it for today. I will get our next one up and running as soon as possible. I hope this helps you out with your studying, and I hope you guys have a really good afternoon, morning, whatever time of day you happen to be watching this thing. All right, take care. Bye-bye.